This is our 310 to 311 review number 10. It's the free response problem, and calculators are allowed. This is kind of a pretty rigorous related rates problem that showed up as an AP free response problem a few years ago. So what we have here is it says we have a conical filter that has a specified height of 6 inches and a diameter of 6 inches, and it is draining coffee into a cylindrical coffee pot that has a base area of 9 pi square inches. Now the depth of the coffee in the conical filter, which is H, is changing at a rate of H minus 6 inches per minute. So we just got information about dH dt. And then we were given a formula for the volume of the cone, and we probably will need to know the volume of a cylinder, which is a pi r squared times a height, and we can't use the same h, so we'd probably use a y here for the height of the cylinder. So we'll do the volume of the cylinder and the volume of the cone. So part A says we want to write an expression for the volume of the coffee in the conical filter as a function of h. So they gave us a volume formula for the conical filter as a 1/3 pi r squared times h. And the instructions are to get it in terms of h only. So that means we've got to somehow get rid of that r, or substitute in some way so that the r is written in terms of h. So if we come up here and we look at the picture, we can see that the coffee creates a cone that is similar to the filter itself. So that means we will have proportional dimensions. If we look at the radius of the original filter, it will be 3. So the radius of the filter, which is 3, will have the relationship to the radius of the coffee. It'll be a ratio that is equal to the height of the filter over the height of the coffee. So if we cross multiply here, we get 3h equals 6r, or r is 1/2 h. So now we have a relationship between r and h that we can use down here. So I can replace r with an h over a 2, square it, and do an h. Now you could get full points if you were here and you just left it. However, if we read further in the problem, we're going to want to find the rate of the volume in the coffee and how it's changing. So that means at some point we're going to have to take the derivative of this. So rather than leaving it as is, we'll probably be better off if we simplify and square and multiply everything out. So if I square this h over 2, I get an h squared over a 4. So that means I'll have a constant of a pi over 12 out in front, and then I'll have h cubed. So for my answer, I can write the volume of the cone is a pi over 12 times h cubed. So notice what they've done for us in this problem. They have given us the picture and labeled things that are changing over time. They neglected the r, and they neglected the depth of the coffee in the base, but otherwise they've kind of given us what we need. So they have done step 1 for us. By asking us to do part 2, they are guiding us through the process of step 2. So in part A, they're asking us to find the volume of the coffee in the conical filter. Now the reason that's a good step 2 for us is if we look at what we were given the dH dt. And chances are at some point in this problem we're going to either be asked to find dr dt or dy dt, or maybe even dv dt. So if we look at B, we can see that we're asking for the rate of the volume in the coffee in the conical tank. So they're asking for dV dt, where V is representing the volume of the coffee in the conical tank. So B is actually asking us to do steps 3, 4, and 5 of our normal related rates process. So I'm going to scoot this up here, and hopefully we can still see it. Step 3 of the process would be to take the derivative of the relationship between the volume and the height. So if I do that, I get a dV dt equals, move through the constant, hit the power, and then hit the h. Once I've done that, I'm ready to do step 4. and 5, which is let's go back and label our picture with the instantaneous information and then use that instantaneous information to replace all the variables that I should know. So we're interested in dVdt, which means we'll leave that alone. Pi over 12 is already a constant. We know the 3 doesn't change. We've got an h, so they told us that h is 2 at the instant. And dh dt, up in the given information, we're told that the rate of h at which that h is changing is h minus 6 inches per minute. So that means when h is 2, I'm going to plug a 2 in here. So the dh dt will be a 2 minus a 6. So we might want to write down up here that dh dt is equal to 6, or h minus 6. You can write that down. There might be a point attached to that. We'll look in a second. So here we are. We've got dv dt. All we need to do is multiply that out, and when we do, we get a negative 4 pi. Now notice they tell us to indicate units of measure and interpret. So that means they're asking us to do step 6 in the process, which is we've got to isolate dv dt, which we already did. We've got to stick units on it. It's a volume change, and volumes are always measured in cubic units unless it's like a liquid measure like gallons or liters, but in this case we're measuring things in inches, so that means the volume will be in inches cubed. So we can write down negative 4 pi inches cubed per, then we go look at our time because we've got a dt on the bottom, and it looks like everything that was given to us is in terms of minutes. So we can now interpret and say the volume of the coffee in the conical filter is, because we have a negative, we would say it is decreasing at a rate of 4 pi inches cubed per minute when h is 2 inches. Or we could say at the instant in question, the volume of the coffee is decreasing at a rate of, however you want to write it. As long as you have that word decreasing, you have the correct units, and it's a complete sentence, you could probably get the full points.